participants. Really happy to be talking to you. As Anil said, the session today is fundamentals of Six Sigma. I have also included some of lean concepts here, though we will focus more on Six Sigma. I'll be talking a little bit about the lean concepts, which are quite popular today, and you will find it useful. I am based out of Bangalore and just 4 months into CII, and as Anil said, I had been a practitioner throughout my career, working like you all in industry, various industries rather, and various geographies, implementing these concepts. Anil, hope I'm clear. The agenda for today is what is Six Sigma. You might already have read, a lot of information is available. We will talk about what it is in simple terms for practitioners. We will go to Lean Six Sigma measurement and then move on to the implementation roadmap. Another part I have added here is preparing for change. While the tools and techniques are important, the change management is also very critical and important in whichever organization you are working in. So we will touch upon that point. So this is something which Edward Deming said, 85% of the failures are expected deficiencies in the system and not because of people. And for historically we had been trying to, whenever problem comes, we hear that people have been told, there have been a work instruction which has been updated, there was a training given, but if process is not improved, the improvement will not happen. As common user today, if we look at a lot of processes which we are consuming from even government organization, public sector organization, the type of improvements which have happened, they have become foolproof. I give an example, simple example of use of SMS as train ticket. It is such a fundamental and excellent improvement for all of us. We used to go to a printer, print the ticket. Before that, we used to go to Windows, get the ticket and then travel. Today, you have an SMS with which you can travel. There is no chance of mistake. There is no effort involved in creating a ticket or chances of defect while you are creating a ticket or forgetting the ticket. Historically, quality had been divided into 3 aspects. So is any business. So we have our financial planning, we have similarly quality planning, we have control, and we have improvement. So we plan for quality, getting the results which we want, our ISO 9000 system, our SOPs, our operating procedures. We do control, we produce something, we check whether it's right or not. It can be in-process inspection or it could be finished product inspection. And then we do the improvement. If the rejection rate is high, or client returns are high, or process capability ratios are not good, we do improvement. I have some statistics on the next slide, which I am showing now. How is the status with regard to quality? These 3 aspects. Quality planning, in most of the organization, it is reasonably good, and in some organization it is reasonably okay. Just give me a minute. Yeah, I was not able to see the complete slide. And in 47% of the organization is not okay. So what I'm trying to say is quality planning is good only in 13% of the organization. In 40% of the organization, it is okay. And 47% of the organization, quality planning is not good. Let's see what is the status with regard to quality control. Quality control, the numbers reverse if you see here. Quality control is reasonably good in 44% of the organizations. It is okay in 36% of the organization, and it's not okay in 20% of the organization. Quality improvement is just reasonably good in 6% of the organization. It's okay in 39% of the organization, and 55% of the organization it's not okay. These statistics throw quite a lot. You should think through in your organizations where we are. Quality improvement is just good in 6% of the organization. There is a lot of gap to be fulfilled. These numbers have changed over a period of time, but still the expectations keep changing. What we are talking today, Six Sigma is a tool and an enabler for your quality improvement and quality planning stages. Quality control, it will be good because without that we cannot survive in the industry, but you can see still 20% of the organization do not have a quality control system. Why it is so? The next slide is just to make it a little interesting, and you can recall in the organization people who create fire, or not really create fire, but if there is a fire, they can solve the fire. They are more important rather than the people who can do quality improvement and prevent the fire. So that culture has to change. It has changed by and large in last decade specifically. Let's look at the historical definitions of quality, conformance to specification. Client has given you specification, say from -2 micron to +6 micron can be your tolerance in the mechanical industry, or client has said my delivery from Flipkart should be within 4 days. So that is a single-sided specification. If it comes in 4 days, you are happy. So that's the quality of definition. Fitness to use is when I bought a product, it should be fit to use. It's not that what I ordered. If I happen to order a wrong book today, I have a choice of returning it, and Flipkart or any other organization is happy to take it back because I can say that what I ordered was not fit. Remember what happens in our workplace. If you ordered some nuts, bolts, or a spare part, and the spare part comes in and then you see it is not fitting, what does the vendor say? It's always a dispute or an argument or a discussion that whether he or she should return it or not. From conformance to specification, we move to fitness to use. We need what is required and not what has been specified. Then came customer expectation. Now we are working with clients, or vendors are working with clients to find out what is good for client. So proactively building a product which is better and better for client. I worked in the same domain for quite some time, and the effort was, you might be users of those products, effort was to build an abrasives which is good for the client, which gives more life, which gives better service finish, irrespective of whether it is specified in the purchase order or not. Then customer satisfaction. Then came customer satisfaction, and finally customer delight. Six Sigma tries to address all of them. When you see the definition, it will be targeting on conformance to specification, and then enabling you to improve upon that and reach to a stage of customer delight. Now I am coming to various approaches to quality improvement. We have all seen quality circles, small group activities, Kaizen, suggestion scheme, task force, Six Sigma teams. Six Sigma teams are no different from quality circle, small group activities, Kaizen or a suggestion scheme or task force. There are certain qualities in Six Sigma team which we are going to talk about, which discriminates to it from others. But it's very similar to quality circle with different type of capability. Quality circles used to take up problem and solve on the ground. Similarly, Six Sigma teams also take up an organization problem and try to solve it. The level of the problem could be different. Their knowledge level could be different from what quality circles used to have. Quality circles used to work on 7 simple tools. Six Sigma teams work on little more advanced tools, which we are going to go through today. What is Lean Six Sigma or what is Six Sigma? Various dimensions. I will go through one by one. It's a metrics, it's a measurement. A Six Sigma organization can tell that I am at Six Sigma level for my purchase order process. I am at 4 Sigma level for my salary processing process. I am 3 Sigma for my grinding process, or I am 5.5 Sigma for my smelter. So you can measure what you are doing. There is a goal for Six Sigma. If I am at 3 Sigma, where am I going to? Am I going to 4.5 Sigma? What's my goal for this year, next year, and what is best for me? The goals are derived from benchmark. They are not internal. The benchmark could be internal to start with. If you have 10 production machines or 2 locations doing the same job, we can benchmark between them. If not, we can get outside benchmark. Today, the benchmarks are available in the market, or we can have some collaborative work and get the benchmarks. Benchmark need not be from the same industry. One example I always give is the ICU preparation and a airlines operation changeover from one flight to other flight and the way ICU is prepared for an operation, the changeover happens. Very similar processes. One can benchmark, and people have benchmarked and tried to achieve good time, good hygienity, and the expected customer delight. Six Sigma is also a vision, what we want to do in long term. It is a methodology, DMAIC. We will learn, define, measure, analyze, improve, and control. It is a culture. When we talk of Six Sigma, we do a lot of training. We build people at various levels. There are people who are subject matter expert, like Master Black Belt. There are another set of people who are black belts. There are green belts. There are yellow belts. So multiple belts are there. There are facilitators. So it is about culture. Everyone talking about it. It's not an isolated activity in one area. I talked about how Six Sigma is different from other tools. So here are some of the differences which are being articulated here. Six Sigma aims as business results and breakthrough improvement. Important keywords here, I will emphasize on it. It always aims as business result. It could be your aluminum consumption. I saw some people from SAIL. So it could be your aluminum consumption in the refining or in the smelter process. I might use some of the terminology I am just familiar to, so please bear with me. It could be aluminum production. It could be cycle time in which the spares come in the company. It could be the time taken to review a new design and launch a new product. It talks about breakthrough improvement. We are not talking about improving rejection from 3% to 2%. It is talking about reducing rejection from 3% to 0.5% or even fraction of percentages. Data driven with the application of right tool. The improvement which we are talking about is not just improvement. We have to back it up with the data. What was before, what was after, how did you identify the root causes, and the right tools need to be used. And there is a reason why we are talking of application of right tools. People involvement and capability building. The third aspect. People involvement is important because organizations are large. Any organization we are working, either we are already large or we aspire to be larger. You cannot do improvement in isolation. You need to build people. The people could, organization could be 100 people organization. Tomorrow it may be 500, 10,000 people organization. You cannot have someone expert coming and doing and solving problems for you. So it's about capability building. So this is the beginning of capability building. You have signed up for this. You are attending and learning something. Today there is an internet available. You can always go back and learn through that. You can buy books, or there can be more structured program which CII or many other institutions do from time to time for building capability. It's a structured execution, and there is a review mechanism. Any Six Sigma organization has structured review from the senior management coming down to various levels, and there is a structured execution process. You have a green belt project, you have a black belt project. It has 5 phases, as I said: define, measure, analyze, improve, and control. And then you do the execution through that. There are toll gates in each of the stage which are reviewed periodically to see that we are on the right track. About breakthrough improvements, I would like to take few examples here, and we have seen in our life many times we say whether zero defect is possible or not. What happens to polio in India? Very sensitive subject and very interesting subject as we have grown over the last couple of years. What has been done by the country? A country like India, geography, the reach, people have tried to reach out, and there had been a structured program to eliminate that. And if those type of issues can be addressed, let's forget that in our industry, whenever we go to an industry, I was in a hospital yesterday, people say we are very different. We have doctors on one side, we have administration staff on the other side, we have housekeeping staff, which is important, we have office clerks and accountants on other side. Which industry is not like that? I have worked in a bank. You have traders on one side, you have people who are making settlements, you have people who are typing and creating the contracts with the customer. Or it could be a steel manufacturing company. You will have accountants, you will have metal experts, you will have chemical expert. A simple product like motor, electrical motor, where I've spent good amount of time, you have electrical engineers and mechanical engineers. So here it is about both coming together, and you have to give better efficiency. Motor, how do you build it? How do you build your mechanical dimensions which are correct? How do you build the assembly line which is correct? How do you deliver a product which is required by the customer? How do you test the product and deliver that sort of delivery to the client? And in the quality front, I think last couple of years had been very good for us as users. I will go back to the same example, getting SMS and using SMS for traveling. An Indian railway organization making our life so simple. Or the e-commerce today, where we go and buy a product, or the cars which we are using today, the type of designs we get for lesser price than what you used to get, or electronic products we have, or even this simple example of doing WebEx today and reaching out far and wide. So there had been a lot of improvement, and we have seen defects going down drastically, costs coming down, processes becoming efficient, and customers getting delighted. I'm coming down to Lean Six Sigma measurement. This is an example from cricket. Many of you may be interested in cricket. Does average really matter? Now you can observe that an average delay for a train is say 30 minutes or 10 minutes or 5 minutes. There are sites where you can go and see that what is the average delay for the train. But the day you are traveling, if the train is 10 hours delay, how does that average help you? And that's what happens in the organization. I will take you through a couple of examples. So here you see one of the cricketer average for one day international is 37.9. Hope you are able to follow me on the table. Average is 37.9. On the test cricket 44.83, 2020 79, and IPL 109. Does this average really help? The person, sorry, I am here. So average for IPL is 32. So highest score is what? Varies from 264 to 79. Does this really matter for the winning a match? This average, it does matter, but average alone is not enough. If you keep deciding based on average, we will be in chaos, and we will see our industrial life example. So here is an example on delivery schedule. So delivery committed to the customer was 25 days, and our performance is 20 days. Will the client be happy? Looking at these averages, definitely client should be happy, because client said, I want delivery within 25 days and our average is 20 days. Let's see what's happening here. What's happening here is we have an average of 20. This is a typical normal distribution curve which looks like a bell shape, and we use very frequently in our quality field and specifically in Six Sigma. Customer specification target value is 25. We are 20 days average, which is very good for the for internal understanding. But when we look at the average, look at the daily performance, the distribution looks like this. So you have so much of observation or so many observations when we are going above the specification limit, and that's where the customer will be dissatisfied. I'll take one more example from manufacturing. This is about, say, cement bag we are filling, or it could be bread. Of course, it cannot be 25 kgs, then the weight will be much lesser. So a cement bag has to be 25 kgs, and we are at average 25 kgs. Customer should be happy, and customer is not happy because you can see here that when we are targeting and running the process at 25 kgs, we have many times getting weight which is lower than specified, and we are getting something which is higher than specified. So if we are filling higher, this is a business loss. We are giving material which is higher than specified value, and if we are on the lower side, then we are giving lower value. It can be a customer dissatisfaction also, and it can be also a regulatory issue or a compliance issue as far as weight and measure is concerned. So the average is not helping us completely. I can give you an example. One of the products of the noted chocolate manufacturers, where they were packing 10 pieces in a box and measuring by weight, the sales went down because when kids are buying, they see always the 10 numbers are coming. And sometimes if 9 are coming, they cannot distribute equally to the friends or the family members. And they did notice that we might feel that the customer is not noticing a difference of 200 grams here and there, but in many cases, customer do observe if there is a sustained reduction in the value what customer is expected to get and what he or she is getting. Let me take another example, the same example which we discussed about the delivery time or the cycle time. Here what I am trying to show you is the cycle time used to be 25 days. We improved it to 20 days. Is it a real improvement? How much of the improvement it is? We go out, advertise and say we have achieved a lot of improvement in our process. Now we can do it in 20 days and things like that. So this was the distribution before the process was improved. And after improvement, the process looks like this. There could be customers in the earlier scenario who were getting delivery somewhere here, 20 days, 22 days, 21 days. Even now they are getting the delivery in the same amount of time. So there will be a set of customers which will not see the real improvement in the process. That's what Six Sigma techniques and tools helps us to magnify, understand what is the real gain and or real improvement, what we are actually delivering. To sum it up, Six Sigma helps us to understand the average and variation more. So going back to my first statement that we measure average, which is not really sufficient, we need to measure variability also. Six Sigma helps us to measure the variability, understand what client really is getting and what the client should get, and make an improvement which make a perceived change to the client. In this case, it was measured that only 50% of the clients are able to see what is the real difference. Moving on, the same example explained in a little different way. I will spend some more time on this. If you see the bottom curve, this is the output which you are seeing. You can imagine your 25 kgs bag, which was minus here and plus here, or you can imagine the bread which we buy, or you can imagine the outer diameter of a shaft which you are producing, or you can imagine aluminum consumption in a steel plant. Say your consumption is supposed to be 0.5%, or say 100 rupees per ton, and then it is varying. For one lot it is 98 rupees, and for another batch it is 102 rupees. So this is the sort of variation. What Six Sigma does is it tries to break up this variation. I will take the simpler example of bag weight. So bag weight, if you measure, say in shift 1, if you measure, quite likely that your the shift 1 variation was something like that. Shift 2 was like this, shift 3 was like this. Or it could be 3 machines. Machine 1 variation is like this, machine 2, and when you are seeing overall data is like shown in the graph below. So what Six Sigma is doing is it's trying to break up the variation and trying to show you where the variation is happening. And this is what we exploit to identify the real reasons for improvement, the variation, and then how to improve. What's the statistical objective, or what is the numeric objective of Six Sigma? You can have a process which is on the right side. We have too much of variation. These 3 lines are, this is the average line. You have a lower specification limit, which we will talk more about, and we have an upper specification limit. Your objective could be to move the process from here to here. This could be one objective. Or you might have a process which looks like this. That is, you have a process which is not centered, but the variability is low. In this case, you have to move the process to this area. Again, taking the example of the bag weight, which is much simpler to understand. If the bag weight variation was high and we were here 25 kgs, we were having higher variation, we have to reduce the variation and move here. Or it could be the bag weight variation was not a problem, but we were supplying something which was on the lower side. This need to be moved on the right side or on the center side. This is the formula for Six Sigma. I'll take a little more time to explain what the formula is. You need not be worried in today's environment about this formula, because you will never be doing calculation by hand. You will either use your calculator or our popular Excel has all these formula which you can use. In fact, it has more than what we think of in its inside. We have most of the statistical tools which are there in the Excel. You don't really need Minitab or any other software. Most of the analysis can be done. What will be different is a Minitab, which is a software used for Six Sigma, can give a graph which is more beautiful, but Excel can give all the analysis which is required. So coming back to this formula, there is a term standard deviation, which is denoted like sigma, Greek symbol, which we have learned in school. You have a square root. This is the summation sign, which is 1 to n. Capital N denotes the population size. I will talk about what is population. Xi is the individual observation. So if in school there are 100 students appearing in 12 standard, X1 is student 1 marks, X2 is student 2 marks, X3 is student 3 marks, and X100 is 100 student marks. Mu is the average, which is nothing but addition of X1 to X100, that is marks of 100 students added up and divided by number of observations. Make a square of it, divide by number of observations, and get the standard deviation. So this is the standard deviation for population. Population is nothing but, in this case, if there are 100 students passing out 12 standard from school, this becomes your population. But you may also decide that it's not possible for me to study 100 students. I will only study a sample of it. So I may cut down my sample size to say 10%. I will only pick 10 students and then study them. It's not a good idea to just take a sample of 10. In statistics, we say that if there is a sample of size 30, it's adequate enough, or minimum size of 30 is good enough. So we'll pick 30 and observe those 30 only. Now we are coming to the sample. When it comes to sample, the formula slightly changes. The sigma becomes S. The sigma, which was a Greek symbol, becomes S, which is English alphabet and standard deviation. The formula remains the same, Xi minus X bar. You can see that mu has changed with X bar, and the sample size changes, becomes n minus 1. Excel has both the formula, the population formula and the sample size formula, which gives you S. From here we move on to how we calculate the sigma level. Sigma level is measured on the two sides. You have normally two specification limit. One is upper specification limit and another one is a lower specification limit. So we calculate sigma level on both the ends. Upper specification limit is USL minus X bar by standard deviation, or sigma level lower specification limit is X bar minus lower specification limit by a standard deviation. Few terminologies to be remembered here. Sigma level ZU, that is Z on the upper side of the specification, and sigma level low on the lower side of the specification. USL minus X bar divided by standard deviation, and X bar minus lower standard deviation, lower specification limit divided by standard deviation. Let me take an example here. Say you are measuring consumption of certain additive, and the consumption of additive specified is 10%. You can have upper specification limit as 11%. You can have lower specification limit as 9%. So your formula for sigma U will be upper specification limit, which is 11%, minus observed average divided by standard deviation, and sigma lower side will be 9 minus lower specification limit divided by the standard deviation, which will come from the data. Excuse me, I think we are going backwards. I will come back. So this is the formula. Now we will try to understand this formula on these pictures. You have two normal distributions. How do we get these normal distributions? We collect data. we draw a histogram, a simple histogram, and then draw a smooth line on that. We can get a distribution like this, or we can get a distribution like this. This distribution, the centering will depend on the average, which is here, and then the spread will depend on the standard deviation or variation. So in this case, the variation is much higher. You have certain number of observations which are below lower specification limit, and you have a lot of observations which are above higher upper specification limit. So this is something which is a rejection. It could be a rework, or it could be a client dissatisfaction. What can be done to eliminate this part, and what can be done to eliminate this part? If you have to eliminate only one side, you can always shift the graph on, or the average on left side, and eliminate this rejection on the right side, but you will end up having higher rejection on the lower side. The best way to reduce this variation, this is by reducing the variation. You reduce the sigma value or the standard deviation, and get the standard deviation which is half of this, and you will get a curve which is here. So you have much lesser variation on the upper side and much lesser variation on the left hand side. Very important aspect when we hear about Six Sigma, one is it scares us, will I be required to achieve Six Sigma level for all my processes to be at Six Sigma level? If a company is following Six Sigma, does it mean that it will have no rejection? That's a myth. That's not reality. And I will take an example of airlines industry. So if airline industry is following Six Sigma, what you will like to see at Six Sigma level? The safety you will like to see at a Six Sigma or even 10 Sigma or 12 Sigma level. The on-time delivery you will like to see at Six Sigma level. You will like to see the time taken to give you a boarding pass at a Six Sigma level nowadays. You will like to see the cabin hygienity at a Six Sigma level. However, baggage arrival time, how much time it takes to deliver you back, you might be happy with the 3 Sigma process. 3 Sigma process means that there will be 680 delayed articles out of million process. So if a airlines is delivering 1 million bags to the customers, 680 will be delayed. So that's I think fine for baggage delivery. Or you may like to have 4 Sigma level for baggage delivery. So it all depends on the processes, what Sigma level is right for me. It may not be economical to achieve 6 Sigma level for all the processes. Let me now come to Lean. Lean has its own history. Edward Deming, of course, is more from PDCA, problem solving, quality field. We had several gurus in Lean. Of course, the benchmark in Lean is the Toyota Production System, which is being followed, and it's very interesting how they have standardized the processes and how they have implemented to create lot of efficiency in the process, lot of on-time delivery and the new product, and one can see, because it's automobile, we can all see how these things have helped the organization to be more efficient, more profitable, create new products, and it's a very complex machine. I would like to share an example. Recently, I was in one of the plants in Bangalore which manufacture apparels, and that plant, I'm not sure whether one of you are from that. The list I saw, none is there from you. I will not use the name of the organization here, but the organization works on TPS or Toyota Production Systems at probably 1,000th of the cost which automobile company will be working on. A suit or a coat is, the order is received. The 2 pieces which are produced are of entirely different type. They are different in shape, they are different in color, they are different in size. They are manufactured. Hundreds and thousands of people working. The level of education level of people is just average or below average. And the variation is so high, very sensitive product, a small error the client will not accept. The message what I want to give here is Six Sigma is not about sophisticated process, automated process, or a costly process. so is lean. These can be implemented in any of the processes. Coming to one or two examples which I have seen in last 20, 30 or 40 years, each one of you have seen how many times a newspaper comes late. I have worked in printing industry 30 years back when we used to have one flight from Bombay to Delhi. Have you ever observed the newspaper coming late? There could be floods, heavy rains, strikes, burns, external environment may be so bad. We will talk a lot about Dabawala, good example. Of course, it has some negativities attached to it and some concerns attached to it. The way they are carrying out things in the local transport and carrying a lot of baggage on the head. Imagine newspaper vendor, how many resources they have, getting paper, different sort of paper from different location and delivering to you on time every day. I think you should go back and calculate the on time percentage and the right paper. Imagine a day you don't get Times of India and you get Hindustan Times if you are in North, or you get Deccan Herald, or because instead of Deccan Herald you get Times of India. What do you feel about the newspaper vendor? And it very rarely happens. I will suggest you use the formula which I have given and calculate the sigma level for your newspaper vendor. You will get a realization that Six Sigma process or a lean process need not be very sophisticated. It can be achieved for very simple processes and can be delivered day in, day out, in spite of the variability in the environment, in the organizations. And you can do the right the first time, you can do on time, and you can keep your customer happy at a very low cost. Moving on to the lean principle, specify value. What is the value? And this is very dynamic. I'll use the same examples which I have been talking about. The railway ticket had a huge value. The airline ticket used to be, I think, the jacket used to be 4 or 5 pages. One of my colleagues worked in perfecting the system for printing those airline tickets which do not exist today. So what you thought as a value yesterday is not a value today. And we can see a lot of examples of that. What was value today and a huge value today, and we were investing, and I have one example towards the end of my presentation, is not the value tomorrow. So think about what is the value. Will it remain value tomorrow? I have worked in a picture tube industry and worked on a project improving the efficiency of an electron gun. That electron gun is not required by anyone today. Our pagers to WhatsApp. You can imagine, pager used to be one person has to call to send a message. Now today, while you are talking, you can send a message on WhatsApp and it's available simultaneously to the people. So specify the value, and it's not easy. It's not easy to specify the value, and particularly when it comes to disruption, that what we are doing may not be applicable tomorrow. This is true for process industry also, or for any of the industry. I recently visited a place where the welding is done without any external medium. They are using vibration and heat to join two sheets of same material and creating a joint which is defectless, which is much cost effective. This company manufactures machines for that. So there are a lot of things which are happening, which will and we will see that the value of what was there in past is not there. There are aircraft bodies being manufactured with aluminum and acrylic fiber, so change from aluminum to that. A lot of cars being manufactured from steel to aluminum, or aluminum to some of the synthetic material which are going. So think through what is the value in what you are trying to do. Identify value stream. How this value is delivered. What are the stages of delivering this value? It could be having 5 steps and 4 decision boxes in between, or it could be a straightforward process. Create flow. Make sure that there is a flow. What it means is not too many handoffs. I will pick up some example from banking when we are talking of identifying value and creating flow. It's just 10 years we have, or not even 10 years, we have e-commerce, so popular. And it is just probably 15 or 20 years we had ATMs. We used to go in the bank, stand in a queue, fill up the check and go and get our money. How tedious it was. And if people in my age group are there in the call, they will remember that how the signature was getting verified. Today there is a PIN, there is a one-time password. So the signature verification was of value yesterday, it's of no value today. Today you have one-time password which comes on your phone number. You have so many sites where you can log in using your phone number. So no need of remembering the login IDs. But how much time organizations took? There are organizations which still ask for login ID, and there are organizations which work on your phone number. So see how things are changing. The value dimensions are changing. The flow of information and the flow of work is changing, and the value stream is changing. So many unnecessary things are getting eliminated. Coming to creating pull, normally historically we say have good number of inventory available, and then you can service the client. But what is pull? Dell is an example for pull, where you can go and order your laptop, and once the order is placed, the manufacturing starts. Of course, there are innumerable number of examples today where you order a thing and then it is delivered to you rather than keeping inventory in the shops. Attain perfection, zero defect in whatever we are doing. I use some example, common example, and the product examples. I give an example of newspaper. Your newspaper cannot be of different brand than ordered. So there is a perfection in that, or near perfection in that. So these are 5 lean principles. Work on the value, what is value, and it is easier said than done. A lot of innovation comes into picture here. Identify value stream, create the flow so that there are no handoffs, there are no things going back and forth. Create a pull so that things are done when there is a demand. You don't create inventory and keep it, and obtain perfection. So it happens. Quite simple and powerful principles which can be applied and have been applied to get what is expected by the client. Now let's come to value added and non-value. Again, a huge debate. When we are in classroom, I think maximum time is spent on what is value added and what is non-value added. In my experience, none of the process has more than 10% or 15% value added activities. We might call it value added today, but it may not be really value added. It becomes value depleting over a period of time. There is an essential non-value added activity. So always there is a debate whether inspection is value added or not. It is value enabling. It cannot be value added. Inspection can never be a value added activity. It can avoid failures, it can avoid mistakes, it can avoid the defective part to the our client, but it's not adding any value. Customer doesn't ask us to do inspection. We are doing because our processes are inefficient as of now. Then there are straight away non-value added activity, which is of absolutely no value. I will give you an example again from bank. 10 to 15% of the time is spent only on creating reports. Let me come to our manufacturing organization or more a service organization. How much do you think is an effort in processing salaries of employees? Huge effort. There are 3 departments which work, and relate this to the earlier slide which I was talking about. How does the salary get created? The attendance flows from one system to other system. The finance is sitting with the money. The HR is sitting with the salary details. And all this information is coming, it might be happening in the back end and not seen by the people. But so many things are there. Is a leave portal which is giving leave information. There is a salary portal which is giving the salary benchmarks. In some companies today there are reimbursements which are coming through salary. So another system giving. And all this data is coming in one area and salary is getting processed. So many steps there, and if you go and draw a value stream for that, you will find so many disconnects in that, so many opportunities for improvement. It applies for purchase order processing Or it applies for invoicing process as well. How much time it takes to create an invoice? How do you get the money back for the invoice which you have raised? It of course equally applies to any of the assembly or manufacturing process. I will move on to the seventh type of waste, transportation. Transportation of raw material. From the raw material stores, it could be a spare for maintaining the plant, or it could be a raw material which goes. How much is the transportation? If you measure, you will find opportunities for improvement. Inventory, how much is the inventory? There is a lowest order quantity, or it is just when finish you order. People have improved drastically on this. I can give you an example of cement plant where I was working. The time taken to turn around the truck from the time it enters the factory and it goes out. Phenomenal change. And you can imagine today's plant, the rate they produce, how many trucks are coming and going back. So this is for finished product. You may have equal number of bogies and trucks coming in for raw material. So this gives a huge opportunity. Motion. How much is the motion of material or people? Service industry, it will be more of people or clients, and in manufacturing, it will be more of material. Waiting time. How much is the waiting time when there is a breakdown? We are not able to repair because there is the spare is not available, or one raw material is not available, and the WIP is stuck. And I'm working on a proposal right now for a power transmission company. Suppose a small spare is not there, they will not be able to erect one tower, and what is the loss? What is the revenue loss? You can imagine. Over processing, finished good inventory, obsolete material, huge opportunity there. Overproduction, producing more than required, producing defects which need repaired or which have to be scrapped, or the skill. The skill comes because now there is a focus on a lot of knowledge worker. Even in manufacturing industry, you have designers but not being utilized. I will give you an example where, say, designers are working more to solve day-to-day firefighting issues or the shop floor problem, and they are not able to build the new designs which are required by the client. So that is a waste of skill in the organization. So these three slides, what I have talked about, very simple concepts, lean principle, think through that. Even if you apply in a small way, you will see huge benefit, and you personally will learn quite a lot out of them. How do we improve, or how do we eliminate this waste? There are various ways. There is SCAP, which is eliminate, simplify, automate, parallel process, or combine. Here is one particular acronym which has a lot of information, and one can remember easily. Substitute, change with something else. So dot matrix got replaced with the laser printers, and then printers were eliminated with SMS or some other medium. I talked about aluminum instead of steel, and then synthetic material instead of aluminum, and so a lot of things are getting substituted. Glass replacing concrete, so there can be, the walls are of glass, so many buildings today. So substitute, find out a different thing for the application of what you are doing today, because the resources will become costlier, and unless you go in for some substitute which is cheaper. In banking or a service organization, substitute means get a lower, put the high caliber resource on high caliber work and bring in people who are less skilled and build them. So that is substitution. Combine two processes. Very interesting example. I was giving salary processing. We have 3 departments work, and still many organizations we have to deal with 3 departments to get anything clarified. So in Karnataka specifically, those who are from Karnataka will know that all government services can be obtained from one window. There is a Bangalore one. You can go there and get service for your water supply, power supply, whatever services, whatever taxes you have to pay, you can pay on one window. So other states might also have. So combining services make customer delighted. It reduces the resource quite a lot in many areas. Adapt. When I say adapt, I give an example of an ICU and a airlines. Adapt from different industries. So many best practices come from different industries. It need not be from the same industry. So automobile companies, how they are procuring material can be benchmarked from a hospital or from a textile company. Or I may talk about a textile or apparel company which benchmark Toyota production system from automobile company. The bank where I used to work, we benchmark quite a lot from Ford on Toyota production system. So it's not necessary the solution is lying within your area of work. Adapt something which can be of use to you and give you breakthrough improvements and coming from other industry. Magnify or minify. What does it mean? When the defects are there, we may say 1%, 0.5% defect. But if you count on an annualized basis, what is the waste happening, then you can understand what is the impact of that. So magnify what is happening, give it a shape which can be seen by everyone. Minify, when I see, get into the depth of it, micro level, and try to understand what's happening. Put to other use, you can have alternate use, people rotation, and multi-skilling is something which is pretty old, 15, 20 years or even more than that. A person earlier who used to operate a lathe machine only is operating lathe machine, but you can have a person operating lathe machine and operating grinding also, or doing assembly at some point of time. So put to other use, it can be about resources, it can be about material. Raw material standardization or your component standardization. One example I can give is in one of the plant where I was working, we had 900 types of hardwares. So 900 types of nuts and bolts. We standardized, reduced it to some 25 or 26. It takes time because a lot of design change has to happen in the fabrication and multiple processes. But can we have one product being used by multiple processes, or can we combine? So two type of nuts and bolts being used for two products. Can we combine and have one common part number which can be used for both? Eliminate, elaborate, eliminate certain number of steps, eliminate component, eliminate certain parts if they are of not use. Value engineering comes into picture there. Elaborate what is the role of that particular part and eliminate that. One very, very good example is of elimination is mouse and with the touchpad, and touchpad with the touch screen now. And it took us time to get adapted to that. But there are machines which doesn't have mouse, which doesn't have a mouse pad also today, which doesn't have a keyboard also, and those things are eliminated. Reverse rearrange. Sometime it happens that if you reverse the order of the process, or if you try to rearrange the process the way it is happening, then it is much more efficient. What we achieve out of this, whatever we have talked about, what we achieve out of it is process efficiency and effectiveness. There is a difference between efficiency and effectiveness. Efficiency is doing more with less. So if I was using 105 rupees material to produce something which is valued at 120, now I use only 100 rupees, I am more efficient. Or if a person was turning around 10 components or 10 transactions, now the person does 12, it is efficiency. If my production was 15 tons per hour, I make it 17 tons per hour, it is efficiency. But effectiveness is doing the right things, doing right the first time. So that is what is effective. Lower rejection, smooth first time right, no back and forth, no handoffs, that is effectiveness. It also helps in performance management. And how does it help in performance management? We talked about capability building. It helps in building capability, building the leadership pipeline. It helps in measuring what is happening, who is doing what, how much everyone is doing. It helps in capability building, of course, and it helps in changing the mindset and the behavior of the organization. While the fourth one is little subtle here, but unless this happens, nothing else can be done. So it changes the mindset and behavior. Why it changes mindset and behavior? Because you are getting in data here. You are talking with data, and I'll just quickly jump onto some of the slides which I showed. If the target was 20 days and my average was if the target was 25 days and average was 20 days, no one can say that there is an opportunity for improvement. There is no way anyone will say that there is an opportunity for improvement. When you draw this curve, which is simple, get 100 readings, get 30 readings in Excel, give a command will give you this graph. You draw the limits there, and you can see how many of your customers are dissatisfied. So it is helping you in identifying waste in your organization, identifying things which are not satisfying the client in the organization. Another example where you said that you have improved process from 25 days to 20 days. Who will question it? Sounds like a very good improvement. 20% reduction in cycle time, everyone can celebrate. But when you collect data and put it, you know that you haven't done your job yet. What you need to do is either reduce the variability further or pull down the average. And that's what we saw here. So you have a process running like this, you have improved, but still there are a lot of rejections happening either on one side of the tail or both sides of the tail. You need to reduce the variability and you need to pull the average, which is centered and hence delivering to the client requirement or the customer requirements. So overall, these type of programs deliver efficiency and effectiveness. You can use Lean or Six Sigma depending on your application or situation. Performance management, it helps in identifying when I am saying that I have improved, whether I have really improved. In this process, I am building my capability and learning something which I can use for my process or for other processes or to train people. It builds a mindset and behavior of improvement. It creates a confidence that we can do things differently, we can do things better. There is a softer aspect in doing this. When you go back and try these things, and I will strongly recommend while it is a 90-minute session you are undergoing, do some calculation. I gave you an exercise of the newspaper vendor. Go back and calculate that how much time it is on time, how much time it is what you required. So do those calculations and you will find some interesting things, and it will also give you some experience. Then also try in your organizations, take up an area, apply Lean, apply a Six Sigma, take up some data to Excel, do the analysis. What will be important is build trust. Build trust that this is not an exercise for fault finding, this is an exercise for improvement. Empower employees. When I say empower employees, there was a time when getting data is difficult. There was a time when there were functional boundaries. There could be still in organization. So we will have to get that empowerment. Share what you are trying to do with your functional heads, with other people, so that you have freedom to get the data, analyze, and communicate your findings. Eliminate unnecessary work. Don't think that it is tedious and time consuming. Do it in a simple way. Create a new paradigm. Pick up an area, improve, which will create a new paradigm for you and which will create a new paradigm for others also. Many examples of how things change overnight. Swiss watches, which were more the wound basis or mechanical watches, they were replaced with the digital ones. Suddenly the change happens, and then Swiss industry was not knowing that this change has happened, and they lost all the market shares. So there are a lot of industries. I can give few more examples of things like Encyclopedia Britannica. We used to take pride in buying it and keeping it home. The company is nearly on bankruptcy or already has got been corrupt. Reader's Digest, it used to be such a glorified organization, big organization, but not for changing. They are in trouble today. So there are a lot of organizations which have changed, migrated them to a total different environment, and you can relate to some of the concepts studied here. Let me move on because we have limited time. We have Anil, we stop for the question answers in 10 minutes.
Yes, sir. We can do it in 15 minutes more, sir. Not a problem.
Sure. Thank you. Let me come to implementation roadmap. We have learned the concept. We have learned how to do it in a very short duration. There is a structured way of implementation, and that's what makes Six Sigma strong. Y is equal to Fx. Don't get scared by this. Simple formula, simple rule, and let me take a simpler example. What makes a student successful in an exam is a function of x1, number of hours of study, x2, the teacher's quality, x3, the quality of friends he or she is having, x9 is number of extracurricular activities and things like that. So any output is a function of one or more inputs. The quality of food is depending on what is the quality of ingredient, what is the composition, what is the recipe, and things like that. So any Y efficiency is function of, say, power efficiency is a function of how efficiently the plant is running. Is the preventive maintenance happening on time? Are the raw material quality all right, and things like that. So any output is a function of several X's. So this is the Six Sigma level, the language which we use. There is an output Y, which is a function of multiple X's, X1, X2, X3, Xn. There are various characteristics of X, Y. You need not worry much about it. If you remember that my output is a function of X1, X2, Xn, that is good enough. The cycle of change in Six Sigma is you have a practical problem. You have a practical problem that raw material consumption is high. That's your practical problem. Or the cost of the motor which I am producing, the induction motor which I am producing, is high. That is your practical problem or the business problem. You convert into statistical problem. Statistical problem could be the copper consumption in my motors is 3% higher than the benchmark numbers. So you see the difference between the first statement and the second statement. You are changing that. So my copper consumption is 3% higher, and that is high in certain type of motors. They are high in large kilowatt hour motors or low kilowatt hour motors or a specific type of design and so on. And if I reduce it from 3% to 1%, organization will benefit say 2 crore rupees a year. Another example, my productivity is low, or I need to have higher profitability. Instead of, you can say that my tons per hour in cement mill is low, which is becoming a bottleneck for me, and I want to improve it from 15 tons per hour to 17.5 or 18 tons per hour. Remember, we are looking for breakthrough improvement. We are looking for use of methodology. We are looking for data and measurement. Then you find out statistical solution. You can say that my tons per hour is 15 today because the moisture in limestone is high, the quality is not good. These are the two factors I have identified. But if I have higher moisture in the lime, I can use a different temperature limit. I have a specification limit for temperature which can be utilized for when the limestone has higher moisture and still get a higher productivity. So that's your statistical solution. You say the limestone moisture is to be contained within, say, 6.5 to 8%. If the moisture goes above 8%, my temperature has to change from current limit to 20 degrees higher or 50 degrees higher or 100 degrees higher. That's your statistical solution, which gives me result that is my tonnage per hour is higher and also my energy conservation per ton of material produced is high. So this is the very logical cycle. It doesn't happen so logically, and what gets missed out is the statistical aspect. This has been combined and given the name of define. You are defining your problem, then you are measuring the problem, you are analyzing the problem, then you are innovating and improving, and finally controlling. Remember our PDC cycle, very similar to it, more structured in terms of rigor of data, in terms of going into the process and quantifying the magnitude of problem and potential solutions. I will skip this for now. We saw this is short term. I gave you an example of machine 1 producing variability of this type, machine 2 producing here, machine 3, but when we see the combined production, it is here. If we are able to split this, it gives us better understanding. I gave an example of motors. Quite possibly the lower frame motor consumption is here, higher frame consumption is here, and special motors the consumption is here. Can we understand why it is? My problem area is this because I'm talking of consumption. Can I improve this further? Some more terminology here. There is something known as CTQ, critical to quality. When we talk of quality, it does mean productivity, it does mean efficiency, effectiveness, all that we studied. So there is something known as critical to quality. When you work on Six Sigma, you identify what is critical to quality. You do not work on many things. I gave you many examples. Copper consumption is high, aluminum consumption is high, my production rate is low, my people efficiency is low, I take more time to deliver what is required to be delivered, and things like that. That CTQ gets converted into key process output variable, which has to be correct and have a specification. We talked about 15 tons per hour is my key process output variable. Along with that, I also need to worry about my power consumption because I can't increase my production by increasing the power consumption. So you say 15 kilowatts per hour at so many 15 tons per hour at power consumption of so many kilowatt hours per ton of material produced. This comes from process. Process has KPIs. I gave you some example of KPIs. It could be related to raw material like moisture content in lime or the quality of coke or size of the coke, or it could be temperature of the kiln, or it could be rotation speed of the kiln, or it could be conveyor speed. So you have so many numbers of input parameters which are going into the process to achieve your output. We'll see how to deal with this and make improvements. The starting point is brainstorming, our simple good old 7 tools, brainstorming, cause and effect diagram, Pareto analysis, and we use those stratification, some of the very useful techniques which come to help when we are doing this analysis. You might start with 30, 40, 50 parameters when you do brainstorming. From there you come down to 10 to 15, then come down to 8 to 10, 4 to 8, 3 to 6. Finally, you come down to something which is critical and which is controllable. If you have to control 30 parameters, it is not possible. If you have 2 or 3 or 4 or 5 or 6, you can improve the process. So the difference here is in our 7 tools, our QC circle also we used to do that. You come down to the number of variables which impact quality and then zero down to few parameters which are important. And but here what you are doing, you are backing it up with the statistical analysis. How do you do this statistical analysis? Often we hear that data is not available. You are starting with 30 variables. So data not available is a common thing which comes up. Go down and say how many variables I have data, how many I don't have. Here is a situation which in 5 areas we didn't have data, 25 areas we had data. So in these 5 areas you can do investigation, go to the shop floor, go to your work area, identify what's happening and identify the significant ones. If data is available, use the data door, do data analysis and find out the reason. There could be a scenario where 25 areas data is not available. You can start collecting data or you can use the Gamma investigation or what we also call as process door. This is a slide which talks about all possible statistical tools, and let me tell you the most complex one here is multivariate analysis, which is used when there are multiple Y's multiple access. Multiple access will always be scenario. Multiple by, I would strongly suggest don't start with multiple by scenario, take one by and try to improve. So this is more complex one. I don't think even 0.2 or 0.1% of the Six Sigma projects will use this methodology. While the users is increasing, but out of 200 projects, one might use this, or even out of 500, one might use. Then comes multiple Y and single straightforward simple graphical tools. Single Y and single X, you will use logic and common sense. And if there are multiple X's and single Y, then you will use some of these techniques which are known as multiple regression, multiple logistics regression, and 2-3-way ANOVA or test of hypothesis. So right now depend more on simple graphical analysis, work on that, and then as required you can start learning these tools one by one. What are the stages of improvement? As I talked about define, there is understanding of the process and then comes optimization. You define the process, you measure the process, you analyze it. We talked how to analyze. You have 30 axes here. You analyze through brainstorming, through multi-voting. Then you collect some data. You use tools given here, some of the graphical tools given here, and analyze the data. And then you improve the processes and finally control the processes. What is important is to start with a problem and define the problem, get stakeholder buy-in, and do something which is significantly important for the organization and gives you enough exposure in terms of how to get breakthrough results. I'm moving on to the final part. We started with what is Six Sigma. We have gone through how to measure Six Sigma in the nutshell. We talked about what are 5 lean principles, 7 ways, what can be achieved through Lean and Six Sigma. Then we have gone through the roadmap of how Six Sigma works. This will not work if you are not able to prepare yourself or the organization for a change. Why change doesn't happen? History. This has never happened before. This cannot be done. In this country, nothing will happen. In this office, nothing will happen. This organization, nothing will happen. You have to prepare for readiness and remember the emotions. And I think we have enough examples when the automation or the computerization comes. People were fighting against computerization. Then there was a stage where people were fighting to get laptop and PCs. So how the conversion happened, it is a slow process. At the same time, you have to remember the pace. So you have to observe what are the sentiments and how to bring in that change in the organization. This is very interesting. I will spend a minute on this and then move on. Normally, any organization or any individual is in this state, providing a containment. I'm happy, everything is fine. Our products are selling. We are working in companies which are profitable, doing good, and demand is going up. Why to worry? Why to improve? This is normally the state. When you try to make changes, then comes denial. This cannot be done here. It doesn't happen in hospital. It doesn't happen in school. It doesn't happen in steel industry. My industry is very different. It's a process industry. It's a very complex technique. After denial, when you come collect data, some confusion comes in. That am I right? How many times I am right? I think it is good, but it has never been done. So the confusion comes, and then comes the renewal. So don't expect that improvements will happen on its own. There will be a lot of challenges. There will be a lot of denial, your self-denial, your own confusions, or your colleagues and peers when you are doing any breakthrough technique or improvement. I will skip this. Of course, the important part, you should be able, and that's what we are trying to build. We are trying to build a competency. We are trying to build the ability. The fact that your organizations have sent you, there is a direction and there is an opportunity. So work with larger organization and come over. You are getting the competency and ability to do it. This is a very good example, and some of you might be knowing how the high jump standards have changed in sports. There was a time when the high jump standard, the records used to be 1.1, 1.2, 1.3, and the approach used was scissors. This was the way high jump used to happen. Over a period of time, it changed to this one, which is known as Western rule. People moved from 1.5 to 2 meters. The y-axis is the meters of record. Then came straddle, which used to look like this, and there was a change from 1.9 to 1.9 to something like 2.1. And over a period of time, it has become Fosbury flop, which is the way it's done today, and moved from 2.1 to 2.4 or so. Imagine that using scissors, was it possible to use 2.2? It wasn't. So you will have to take a decision to take this chance. Looking at this picture, I don't think anyone will like to do this. For doing this, you need coaching, you need extra capability, you need piloting your solution, you need trial and error, you have to measure yourself that it's safe, and you have to work on this method. The need of the hour is going from 2 to 2.3. I don't think otherwise we are beating the competition. And the path can be very tough. So these are the messages I want to give. Path is not easy. It needs structured methodology, structured data measurement approach. Otherwise, a person who was jumping like this will not start jumping like this. Appears to be very unsafe. Our solutions, our breakthrough ideas which will come will appear to be challenging. They will appear to be unsafe to start with. You can't jump on it. You need a methodology to assess the impact and then go for it and get the breakthrough improvement. This is the final slide. I'll come back to this. I talked about resistance. Why resistance comes? I am the expert in this. So how are you challenging me? My processes are deficient. I don't have as sophisticated methods as Flipkart has, but you can see Flipkart had made some of the competitors look at them, global competitors, an Indian company, youngsters driving it. So process efficiency, my processes are not prepared for Six Sigma. Relying on experience rather than data, company culture, individual resistance. So that's what are the barriers. Remember, keep those in mind. The final message I want to give is changes are not costly. On the left side, we have a bottle opener or a can opener. So many companies worked on, and it's not about only one product. There were companies manufacturing this product. They spent their life improving this product and making the product better and better. They invested in manufacturing facilities to create this product. And don't get restricted to this product alone. We talked about pages, we talked about mobile phones of different type, we talked about keyboards, we talked about printers, and there are so many. We talked about steel to aluminum and aluminum to other products. So people talked about so many things they were perfecting, they were spending R&D spend on that, they were buying machines to produce it, and then finally someone comes out with a can which doesn't need an opener. So when you are talking about the value, remember these aspects, small principles, that what is value today, look around yourself, adapt to other industry, other things which are happening around you, and you can achieve. Just to sum it up in another 1 minute, Lean Six Sigma is an approach which is driving you to these four give me a second, which is targeting toward business results. So if it's not giving business results, it's not Lean Six Sigma. We are talking of breakthrough improvement of going from 1.1 meters to 2 meters. We are not talking of marginal and incremental improvement. It's data-driven approach. There is a X and a Y. There is an average. There is a standard deviation. There are some tools which can be used. There is no sophisticated statistics necessary. In 4, 5, 10% you might need some sophisticated, and we are there from CII to help you out for that. Application of right tools, BMAIC, we learned about it. Define, measure, analyze, improve, and control. We learned about the 5 basic principles, 7 types of waste which you can use. People involvement, capability building. This is a beginning for you. You can pick up books. You can reach out to me, or you can reach out to Anil or any of the members. We will help you. We keep announcing more advanced programs where you can be part of it. It is a structured execution approach, and there has to be an organization commitment to make it happen. So with that, thank you and wish you all the best. Anil, over to you.
Yes, sir. So I request the delegates to to type in their questions in the question box. So just we wait for 2 minutes for the delegates to write the questions till that time.
We'll wait for 2 minutes.
Yeah. Thank you, sir. Sir, Mr. Satish Kumar wants to know, in Scamper, should we follow the sequence? Example, first substitute and combine?
So I think very good point. And actually, you need not, strictly speaking, you need not follow the sequence. Sequence has an example. Of course, the sequence has been given so that it becomes an acronym and you can remember better. But otherwise, there is nothing that adapt should be done before, substitute should be done before adapt, and put other uses should be done before combine. Using a sequence will help you in going through each of the approach and getting a comprehensive output rather than getting a sketchy output. Otherwise, there is no need to follow the sequence.
Okay, sir. So Mr. Sumit wants to know why one should go for Six Sigma over Kaizen.
Good, Sumit. Which organization Sumit is from?
Sir, he is from Owen Consulting, sir.
Okay. See, Kaizen is, and that is another favorite thing on my my sessions. There is one saying, 1% improvement by 100 people is better than 100% improvement by 1%. So Kaizen is talking about, and I am quite a good fan of Kaizen, 1% improvement by 100 people and the organization happens. So it has its own place. Kaizen talks about small improvement by every employee, larger number of improvement. Whereas what we are talking here is about breakthrough improvement. I'm not sure whether Kaizen can give those type of breakthrough improvement. 100 Kaizens may be able to do, but today the requirement is to have breakthrough improvement at the faster pace, which needs much more in-depth analysis and identifying the right axis for design result. That's what makes Six Sigma different from Kaizen.
So Mr. Manish wants to know whether Six Sigma can be applied in financial operations also.
Yeah, Manish, I worked in Deutsche Bank for 6 years, and last 3 years I was with Cognizant leading the process excellence for banking and financial services. It can be very much applied and the benefits are huge. If you have any question, you can write to me. I can give you a whole lot of case studies and my experience in that area.
Hello. So there is one more question. What are black belt and green belt? How we will differentiate the same from Nitin?
Sure. So there is a sort of hierarchy which over a period of time it has evolved, and Michael Harry, who started this concept in Motorola and then ABB and then multiple companies, is the initial author, and this has evolved quite a lot over a period of time. A black belt is someone to make it comparative, a quick answer, black belt training is normally 10 to 12 days, who is expert in all the tools which are used in Six Sigma. You have seen the two-way metrics which I have shown. Black belt will know all of them, whereas green belt is just 4-5 days of training. Green belt might not know all these tools and know lesser number of tools. Black belt is someone who will lead the project and make the changes. Green belt might do a lower scope project or work with a black belt and do initial projects and become a black belt.
Thank you. So Mr. Abhimanyu wants to know how we do project selection and project startup procedure.
Sure. So yeah, I missed that slide, and I will see if I can share that. Project selection, but I did talk about it has to be an organization level problem. It has to be something which is having higher impact on the organization, either in financial terms or client satisfaction point of view, or in terms of pollution or your compliance issue. So that is number one criteria. Number two criteria, it has to be in your scope of work. You should be able to solve that problem. Also, the problem, if it is a simple problem and Kaizen can solve, don't take it. If there are number of variables which influence it, then it's better to take it as a Six Sigma project. I gave you example of tons per hour. Tons per hour is a function of 30, 40, 50 variables, which cannot be done by a simple Kaizen, or if you use Kaizen, it will take a long time. So you should choose such problems. Approaches are many. Of course, brainstorming is one simple approach, but I think you can go through net or write to me. I will send you 1 or 2 slides on that.
So Dr. Arohi Kulkarni wants to know what is the 1.5 sigma shift?
Right. See, 1.5 sigma shift is a pretty old concept, and in my view, and this is highly debated topic between statisticians and experts, and I do participate in these debates too. 1.5 sigma shift was relevant when the data availability is less. If you have adequate data, you can calculate short term and long term. So that is one response to me. Wherever adequate data is available for short term and long term, I think you need not talk about 1.5 sigma. When the data is not available, what do you do is, suppose you had limited data and you had created this curve. Hope you are able to see the screen where my cursor is moving. If you are able to create only this curve, you assume that in long term, you will have a shift 1.5 sigma this time side and 1.5 sigma this side. This 1.5 is coming from multiple things. It is from statistical probabilities and something which several authors have studied and brought it out and widely accepted. So coming back and concluding on this question, when there is adequate data, you have this your long-term variability. These are your short-term variabilities, which you can split using statistical analysis. In case you didn't have adequate data to split this, you take one set of data and then say there will be 1.56. It is an assumed number.
Okay, sir. So Nitin again wants to know, mindset plays a very important role. What we do to be positive in Six Sigma?
Okay, some of the answers are here. Don't concentrate on the box and the pictures, see this side. Provide a vision, paint a picture, raise awareness. So raising awareness, this is one of the ways of raising awareness. Talk to people what is Six Sigma, bring in case studies. Luckily, unlike 15 years back, today you go to Google and there is no area where you will not get a case study. You write Six Sigma in steel industry, you will get an example. You write Six Sigma in metal industry, you might not get steel, you may get aluminum or you may get copper. So you write process industry, bulk industry. So create awareness, get the example of what has been done. You talk of hospital, there are examples, there are examples. 15 years back, literatures were not there, case studies were not there. Today you are better off that way. So provide a vision what you want to do. Paint a picture as little flowery presentation of what I'm trying to say here. Say that we can increase the production and it has been done in various plants outside. Listen to the views. People are coming with views, give opportunity for them to speak. Focus on the process and focus on the data. Don't get into debate, and that's the differentiation Six Sigma will bring. You will be able to show the distribution. Yes, I want to go from 15 tons per hour to 17, and anyways 30% of the time we are producing more than 17. So let's observe those 30% of the cases, provide a plan, pilot and deploy. I talked about 30% of the time we are already producing 17 tons. Can we study that and understand what's happening there, and then get the result? Of course, the best thing is to have your own example created and prove it in your area of work, and people will follow.
Sir, Mr. Amit wants to know how do one go for the certification? Is there any organization which provides the certifications?
So CII is one of the organizations. CII IQ does have certification programs time to time, and we keep announcing. This time, Anil, what I will do, I will pass on. The next program is happening at IIM Indore from 16th to 19th of Feb. We are having, and post that we will be having every month sort of program. So CII is one of the organizations which does various level of program. We do in-house programs also for certification for the member organization. Plus Indian Statistical Institute, various consulting organizations, BMG, QAI, they do conduct certification programs.
So I believe only these set of questions are there as of now with us. And I request my delegates, in case if they have any more question or any doubt, they can write to us and I will forward those questions to you, sir. Now yes, sir. So I would like to thank you on the behalf of the delegates also for taking such a wonderful and informative session for us. And now here I also like to inform our delegate that the presentation as well as the recording of the session will be available online on mycii.in, and the links will be shared with you shortly for the same.
Thanks, Anil, and thanks to all the participants for joining this session today. And spread this message, draw out few learnings from this session, and wish you all the best.
Thank you, sir. Thank you very much. Thank you.